Okay. All right. Hello, everyone. I'm Brady Volpe, founder of Nimble This and the Volpe Firm. We are back. Our topic today is what is possible with DOCSIS 3.1 modems, things from SCTE EXPO, OFDMA, and more. Back with us is John Downey, CMTS Technical Leader of Cisco Systems. John, great to have you back again.
Of course. Where else would I be?
Back with us on another Friday.
There you are.
That's right. Well, so back with our, another power of all things DOCSIS. Please drop your questions into our chat window. We'll take those if you have them. If not, drop your questions below. We'll take those as well later on. Be sure to subscribe and give us a thumbs up so you get all of our episodes. John, you and I were at Cable Tech Expo just recently. It was awesome. It was great to be back with all of our friends again. The show went by so fast. Barely had enough time to catch the seminars and also get out on the floor and see all the vendors that were back again and also see our friends. If you missed it, Mia put together a short video. Let's take a look. Okay, so that was just a quick snapshot of some of the things that we saw on the floor, kind of like just that highlight of what the floor experience was like. So if you were at Cable Tech Expo, you kind of knew the experience. It's been a couple years since we've been there. If you've not been to Cable Tech Expo, that's kind of like that show floor experience. We're trying to give you an idea of some of the things you get to see when you're on the show floor. John, I don't know if there's anything you want to throw in to add to that.
Yeah, I remember some of the shots there. We were talking to, I think, Technetics about their new tap. And we mentioned how, we've had taps since the dawn of time of cable. And it's funny how we're still reinventing things, right? Because we're trying to extend DOCSIS. And I always say we're milking the cow as long as we can.
Yeah, no, I was really excited from the show just with how much new technology, we're starting to see DOCSIS 4.0 equipment starting to come out, but it's still going to be some time, I think, before DOCSIS 4.0 actually comes to life. So that's why part of, we'll get into next, actually, there's a question I have coming up about where we can go with DOCSIS 3.1 modems. So as we were talking earlier before the show, John, I mentioned I was just yesterday giving a presentation on OFDMA to the Dakota Territory chapter. So big shout out to everyone at the Dakota Territory chapter, guys. Great chatting with everyone yesterday. I had a great question.
Wednesday?
It was yesterday.
Oh,
yesterday,
okay.
no, it was Wednesday. You're right. It was Wednesday. Yeah, my days get messed up. So I was asked a question about how many modems can transmit at the same time on a 6.4 megahertz OFDMA channel. And I didn't have a good answer. So these guys stumped me at it, and I said, well, I'd get back to them. And I thought it'd be a great opportunity for you and I to chat about this, John. So I figured this is probably an area that you had already looked into. I hadn't had a chance to look into that because I wasn't sure if we'd be limited by bandwidth, mini slots, grants. So, John, what's your take on it?
So it is an interesting question because, with ATDMA, the A part of that ATDM, A, means it's basically bursty, right? So single carrier qualms in the upstream are all bursty, one modem at a time. I remember reading an article about noise contribution saying, oh, you have 900 modems on a service group. Yeah, but they're not all contributing noise at the same time. They only contribute their own noise when they transmit, which is an interesting point. But when we go to OFDMA, just like SCDMA used to be, you have codes. But with OFDMA, you could have multiple modems transmit the same instant in time because they're assigned mini slots. Now, a mini slot is 400 kilohertz. So depending on the subcarrier spacing, which brings another point, a 6.4 megahertz wide OFDMA, that's not even legit unless you're doing 25 kilohertz subcarrier spacing. If you do 50 kilohertz subcarrier spacing, the minimum channel has to be 10 megahertz. And by the way, it's 10 megahertz active subcarriers spectrum, but we put a half megahertz on both sides. So it's really 11 megahertz for a 10 megahertz carrier, and it's 7.4 megahertz for a
6.4. Yes.
So
and I think that's a good point that you bring up, because not all CMTS vendors support both 25 kilohertz and 50 kilohertz spacing just yet, even though it is part of the DOCSIS specification. So you may want to do a 6.4 megahertz channel in the upstream, but if your vendor doesn't support 25 kilohertz spacing, you may be limited to your smallest OFDMA channel being 10 megahertz, to your point, John.
Yeah. So then if it's 6.4 megahertz divided by 0.4, which is 400 kilohertz, you end up with 16.
Where are you coming up with the 400 kilohertz?
What's that?
Where are you coming up with the 400 kilohertz again?
So that's a mini slot. So when you look at the spec, the mini slot for OFDMA is 400 kilohertz. So that could be 8 50 kilohertz subcarriers, or it could be 16 25 kilohertz subcarriers, but it's always going to be 400 kilohertz for a mini slot. And so if I know a modem can transmit one mini slot, that means 16 of those could transmit the same instant of time. 16 times 0.4 equals 6.4.
16 modems can transmit in one mini slot at the same time.
No, 6 modems could be assigned a mini slot. So if a mini slot's 400 kilohertz, then you get 16 of those in a 6.4 megahertz wide channel.
Okay. So 6 modems in a mini slot, 16 modems in a 6.4 megahertz OFDMA channel.
Correct.
So that's the final answer. That's the answer I didn't have for the Dakota chapter.
And there's 2 basic points to that too, is because you could have 16 modems, just in that small channel, you could have a lot more. If you did the math for a 96 megahertz wide channel and divide by 0.4, you end up with like 200 modems to transmit the same instant in time. Take 96 divided by 0.4, whatever the numbers. But let's say we go back to your example of 16 modems potentially transmit the same instant in time. That's not going to work very well for an RFOG solution. When we look at an RFOG solution, we worry about optical beat interference and multiple lasers coming on at the same time in the upstream. If you have 16 modems, 16 different neighbors all talking at the same instant of time, their lasers come on, they all transmit at, say, 1310 or 15, probably 1310. They're all going to collide and have optical beat interference. So OFDMA doesn't bode well with RFOG solutions. On top of that, when you say power levels, if my modem transmits, say, 50 dBmV, that was for the whole channel per se. And technically, when we look at power levels for OFDMA, regardless of how wide the channel is, we usually equate the power level to a 6.4. And so me and you were doing some math earlier, and I have to take a step back. If we know that the modem is only going to transmit one mini slot, which is 0.4 megahertz, and there's 16 of those in a 6.4 megahertz channel, you do 10 times the log of 16, you end up with 12 dB. So what happens
10 times the log of 1/16th, right?
Yeah, so you subtract, so it'd be a negative 12, right?
Right.
Yeah. So if it was 10 times the log of 16 would be 12, 10 times the log of 1/16th would be negative
12 dB.
So if you said, all right, my modem is at this house, it should be transmitting 50 dBmV, the actual power level coming out, if it only transmits that one mini slot, is going to be 50 minus 12. It's only going to be 38. And that might not be enough to even turn the laser on for RFOG. So there lies another problem.
Yeah, and the scenarios that modems are going to be transmitting, and just like you're saying, one small subcarrier, just that 1/16th there are going to be like mouse clicks, or very, very frequent times that's going to happen when, if you're gaming or just clicking on a link or something like that, and that's going to have very low energy. As you're saying, you're not going to turn on the channel. You're not going to create enough energy to turn on a laser in your RFOG solution.
And most RFOG solutions have a certain threshold because they don't want the laser turning on for ingress.
Right.
You don't want some remote control car at 27 megahertz creating ingress, and that turns on your upstream laser. So there's usually a threshold there.
So we talk about the maximum number being 16 modems. We still, I mean, that's the theoretical maximum, right? We still have a capacity issue. You could have one modem that would consume, or just a couple subscribers that could consume that 6.4 megahertz OFDMA channel if they're consuming the total bandwidth.
Yeah, CMTS schedules the time, use it or lose it. So it's like, if you're the only one online and you want more speed, I'll give you all the mini slots in that 6.4 megahertz channel. I'll give you all 16 because no one else asked for it.
So 16 is the maximum, but it could be less than 16 modems if you have subscribers that are consuming a lot of upstream bandwidth.
Correct. But it could be a lot more than 16 if you have a bigger OFDMA block.
Which ideally we're going to be looking for. And I think that brings us into the next section of, we're looking at 4.0 in the future, DOCSIS 4.0, to get us to 10 gigabits per second in the downstream, much faster bandwidth in the upstream. But that's not available yet today. That CPE equipment is not available today.
I just took 90. Actually, it's 95, right? Because 96 is the max channel minus a half megahertz on both sides. So it's actually 95 megahertz divided by 0.4. You could have 237 modems transmit the same instant of time.
237. That's your theoretical maximum.
You don't have that many DOCSIS 3.1 modems in the same service group anyway, but you could.
Yes. Yet today we don't typically have that many, but it's possible. And I had that question too, because I gave my own recommendation, but I was asked, what is your recommended service group size? So how many modems on a node? How many modems on a service group, especially as we're moving into DOCSIS 3.1 and we're trying to achieve this gigabit speed bidirectionally. So, when we talk about how many modems in a service group, we see nodes that are, anywhere from 100 modems or even less to sometimes we see them at 500 modems. What guidance do you give as far as the ideal number of modems on a service group?
Hey, if the president of your company is on a node, then it's one.
That's the ideal number.
Kind of like when you have a food critic. If you have someone that's really active on the chat rooms and stuff, you put less modems on that service group so he's happy. He never complains. So I used to have, it's philosophical in that if you have to provide higher speeds into a service group because competitive pressure, marketing, whatever, you have a bigger pipe to share. So you could afford more people in that area. So the service group could be 500, could be 1,000 customers in the service group, a downstream service group. You might segregate the upstream, into a 1x2, meaning the downstream's 1,000, but it's 500 for each upstream service group. And that upstream could be OFDMA and single carrier QAM mixed together. It's a big enough pipe to offer 200 megabit per second, but most people are only taking 10 meg service or 15 meg service on the upstream. So you can oversubscribe it more. That one becomes fuzzy math. It's all over the place. You really don't know until you look at the types of services they're running and how active people really are. Am I servicing a college town where they're active all the time? Am I servicing a new development where people are working from home? So it's going to create more upstream. Do they have security cameras that are creating more upstream? What Ring doorbells, gaming, and stuff like that. So we can start out with a certain number and say, yeah, that makes sense, but we always try to push that as far as we can because that's how we make money. You oversubscribe, and then you hope people can ring the bell when they do a ping test or a speed test, and then they're happy because that's all they're looking at for their speed verification is they're just going to speed test sites. In reality, we used to say, I give people 10 megabit per second, but the average usage might be only 200 kilobit per second, 24/7.
But I don't think you're recommending 500 modems as a service group size, because what I'm seeing more in the industry is we're trending down to maybe 100 modems per service group.
Of course. We're trying to get fiber deeper, which makes sense. So you can have a fiber node, fiber plus one amplifier, but that one amplifier could be all over the place. So in reality, it's one node and might be 20 line extenders but it's only one in Cascade, right? There could be 20 line extenders, and that might end up feeding 400 people. And then on the upstream, 200 on one leg, 200 on another leg. So it might be 200 per upstream service group. Could be much less. I know Comcast was looking node plus 0, and they were looking at 150 to 200 homes per node.
Right. Max.
So, so then your upstreams even cut down to maybe 75.
Yes. Yeah, I mean, we've seen some customers, as particularly as they go to DAA, they're really trying to push down even less sub 100 modems per service group. So kind of like the Comcast model, but they want to get it less because what they're seeing is that obviously, and this will be very intuitive as soon as I say it to everyone, as you get fewer modems per service group, your return path noise gets much less. And that should be intuitive to anyone, just because you have fewer subscribers contributing to that return path noise. So that's feedback that we're getting from customers. Is obvious as you reduce that number of modems, maintenance per node gets to be much easier. However, you do have a lot more nodes that you have to maintain. We got a comment in from Will in the chat room. He says, cannot stress the security cameras as a bandwidth driver enough. Caused me to switch my primary connection from a DOCSIS provider to FTTH provider. And I think that's an interesting thing. There's a number of security camera providers out there that rather than having all your camera services coming into your internal network, they're starting to stream all their services up to the cloud. And that's like, just continuous upstream traffic being sent to a cloud provider. So that's really changing, rather than being consumers of traffic, now we're being every single home with these different camera providers are continuously sending upstream traffic. And I actually just had a customer contact me today that they were at like 96% upstream utilization. And it's not too often that you see that where you have a lot of upstream utilization issues. It's typically our utilization issues are in the downstream. But I'm not going to be surprised due to, thanks, Will, for your comment. Appreciate that. Because of all the IoT devices, that we're not going to start to see a lot more upstream utilization issues.
I know I'll add on to that. I'll pile on to that. Is over-the-top video. A lot of people are doing over-the-top video. And I'm giving you an example of a local gym I know of that has 4 or 5 high-def TVs all doing over-the-top video. They're all creating upstream ACKs. And the over-the-top video is not, even though it's high-def, it's not taking up that much. Let's say it's like 10 meg a piece. So you might have like 50 meg of downstream traffic, but that 50 meg of downstream traffic could easily be creating, maybe 2 meg of upstream ACKs. And if your upstream is limited to 5 or 10 megabit per second, half of your upstream is already eaten up by your downstream TCP flows. So that then becomes maybe a bottleneck. And then if you're trying to, I knew people trying to, maybe the owner trying to remotely view his cameras. So to create, and the camera might have been a local storage, it wasn't to the cloud. So the cameras weren't creating traffic until he tried to remotely access them. And now that camera system might be slow because the downstream over-the-top video is creating a slower upstream flow. Right. It's kind of eating into it.
So I think that brings us into the next section that we want to talk about is, we have finite bandwidth in our upstream. So DOCSIS 3.1 gives us a lot of bandwidth in our downstream, up to about 5 gigabits per second. But with our existing infrastructure, we can do, maybe if we go to 204 megahertz, about 1.5 gigs. And I think we touched on this when we were at Expo. I want to explore that topic a little bit further of, why cable operators may need to bridge the gap between DOCSIS 3.1 and DOCSIS 4.0 and kind of explore, how far can we push a DOCSIS 3.1 modem today and explain to our listeners, what are our options and where we can go from there. So first off, John, I'll ask you, what is the maximum capacity that we can do today with a DOCSIS 3.1 modem in both the upstream and downstream?
So the modem itself is hardware limited to 32 single carrier QAM downstream, 2 OFDM blocks downstream. They operate all the mod profiles up to 4K QAM. I know in the spec there was a maybe of 8K and 16K QAM, but there's no modems on the market that support that. And I don't think there's any systems. There might be some systems out there that could support 8K QAM. I don't know. Maybe a node plus 0 situation, especially if it was remote PHY node.
Didn't one operator do some testing at 8K and 16K QAM?
There's no modems. So
right.
There's no modems to test it unless they have some type of proprietary modem. All the markets that you could buy today, 3.1 modems are 32 single carrier QAM, 2 OFDM blocks up to 4K QAM support. Upstream, 8 single carrier QAM upstream with 2 OFDMA blocks up to 4K QAM support. I know from Cisco's side, we don't officially support 4K QAM in the upstream because, let's be honest, not many systems could do an MER good enough to get 4K QAM. But I have a few systems doing 1K and 2K QAM in the upstream. And believe it or not, Jason Miller and I have one customer doing 4K QAM, even though it's not officially supported. So they activated it just to see if they can make it work, and they have it working in some situations. So I'm like, squeeze out as much as you can, you know? And if the CMTS and cable modems are smart enough to do graceful profile management, where they can drop modulation on their own when MER is bad or uncorrectable FEC, then so be it.
Right.
You know, so it's kind of nice to be able to use it if you can, and if you can't, the CMTS will automatically drop you back down.
Correct. So even though we can do higher order modulations, if, like you said, if the CPE is not out there, we're still stuck with what we have today, and highs being.
With that said, you asked about speed. So downstream 32 QAMs, 256 QAM is the most you can do for the 32 single carrier QAMs. That's 1.2 gig. So there's 1.2 gig right there. You take a 192 megahertz wide OFDM signal at 4K QAM. I know I'm pushing my limits.
The highest we can do.
Yeah, so 4K QAM, you can get 1.9, almost 2 gig out of one block. So if you have 2 blocks, there's 4 gig there, plus the 1.2 gig from 32 single carrier QAM, there's your 5 gig.
5 gigs.
So
but that assumes there's no noise, no RF impairments that's dropping our modulation from 4096 QAM to a lower order modulations.
And you have the spectrum allocation, you can do that, right?
Correct.
You need 2 blocks plus the 32 single carrier QAM, along with your video, along with everything else that's on your plant.
So 5 gig down, that's 5 gig on the downstream. How about the upstream?
So let's be honest on the upstream for modulation, say 1K QAM. Mm-hmm. I can make 1K QAM work on the upstream. With that and 2 96 megahertz blocks that could fit in a 5 to 204 upstream plant. And because it's a 204, you're probably going to do DAA, distributed access architecture, so you have digital fiber. I'm afraid of laser clipping for anything upstream analog.
There's not going to be any analog optics. We have to eliminate all analog optics, which means we're also getting rid of any type of legacy video.
But it's highly recommended.
Yes.
and it could be not even DAA. It could be the like CommScope and even ATX, who's handling some of Cisco's stuff that we kind of sold off. They're making a upstream digital like BDR. Mm-hmm. Remember the EDR, enhanced digital return, where they digitize the upstream and send it back on a digital link. So that's not quite DAA, but it is a digital upstream, which would satisfy and solve the upstream laser clipping problem. So let's say 204 is their upstream spectrum, 2 96 megahertz blocks, almost the equivalent of a 192 megahertz OFDM block, right? With 1K QAM, you can get 1.5 gig.
Okay.
So the aggregate is 1.5 gig. With a 1.5 gig aggregate, you could offer a 1 gig service to, probably more than a handful of people, because what's the probability of them actually using it and then using all of it and
consistently, continuously? And that's 2 OFDMA channels you're talking about in the upstream. Any SC QAMs with that, or is it we're just using OFDMA?
Well, let's do the math. 5 to 204 is 196, isn't it?
Yes.
Is it?
But
5 to 204 is 190.
It's about 200 megahertz, roughly.
It's about 200 megahertz. So if you have 2 96 megahertz blocks, it's going to be 192. So
you don't really have any room for SC QAM. So what does that mean? What does that mean for legacy CPE, like DOCSIS 3.0, DOCSIS 2.0?
Maybe you have room for one single carrier QAM, and maybe that's just for like some EMTA VoIP or from DOCSIS set-top gateway set-top boxes.
Or maybe your legacy transponders in your power supplies that you don't want to upgrade to 3.1. Exactly. So I think that's an important thing to understand. In order to achieve that 1.5 gigabit per second in the upstream that we want to do, you pretty much have to go to a pure 3.1 network for all your subscribers. And that's a lot of upgrades.
Yeah, awfully close, right? I mean, I'm sure you could rob Peter to pay Paul. You could say, all right, I'm going to do a 96 megahertz block from right near the upper edge of the FM band. So maybe 88 to 204 is a 96 megahertz block. Or no, 108 to 204 is a 96 megahertz block. So you just avoided the FM band.
Yes.
And then maybe from 42 to 85, you do a smaller OFDMA, and then below 42, you stick with your single carrier QAM because business as usual.
Yeah. So that's what I said. We have about 200 megahertz there, but we haven't taken into consideration any exclusion bands, any places we're going to have to notch out subcarriers due to known impairments or known signals that are going to be in there that are already going to be taking away from that capacity that we have. So being able to put SC QAMs in there is going to be really, really hard. So Jeremiah asked in the chat room, he says, are there any possible modulation enhancements that are supported with DOCSIS 3.1 chipsets? Is 32 SC QAM at 512 or 1024 with smaller service groups? So I think he's talking about, do we have any capabilities with our SC QAM to increase the modulation?
No.
So unfortunately, Jeremiah, as John and I have been talking about, the spec is locked. The spec is locked into place. We're not increasing modulations anywhere. We kind of have what we have. So I think, how could we get more out of it, John? Because, we're looking at only, well, not only, but, 5 gigabits per second in the downstream is a lot. 1.5 gigabit per second in the upstream is a lot. But, in the upstream, we have to go to 204 gigabit per second. DOCSIS 4 would obviously be the next step. How could we get more out of DOCSIS 3.1?
So there's no, assuming you have spectrum available or you make spectrum available, you could do more than 2 OFDM blocks on a downstream. If your CMTS supports it, if your, what else would be out there? Really, it's just the CMTS. RPD, if you have DAA and you have a remote PHY device or a remote MAC device, does it support multiple blocks? With whether the CMTS, wherever the physical layer is being generated, can it generate 4 blocks? And what good is 4 blocks? Well, if I could do 4 downstream blocks and I could load balance modems across it, instead of making my service groups smaller, you just made a bigger pipe that people can share and you can load balance. So even though my limiting factor here is the modem itself, in theory, you could have 2 modems in somebody's house where one modem locks on the first 2 OFDM blocks, and the next modem load balances over to the other 2 OFDM blocks. So it's on the same cable plant, but it's not on the same channels. So now you have 5 gig on each modem. So technically you have 10 gig to that house.
So I like the idea, 10 gig to the house, and I'm going to get to Mel. I'm going to get to you in a second there, but if you have, if you only have the capacity of 5 gigabit per second and you're doubling the modem, aren't you risking overloading the channel? Or are you saying that by adding additional OFDM and OFDMA channels, you're not going to overload that?
Correct, because it's not going to be on the same. They're not going to be on the same channels.
And that's where the load balancing comes in that you're talking about, correct?
Yeah. Yep.
Okay.
Yep. So then you have some logistics there on how to load balance properly, make sure load balance. And let's take a step back and say, why do people want this type of speed? It's not for a single flow. It's not for one application. There's no applications out there. There's no doctors doing holographic surgery from their house. I don't need that speed for one application. I have kids, I have DVRs, I have cameras, I have 5 different devices. I have a lot of different flows going on at the same time in my house. So I might want 5 gig, but not for one application, not for one PC, not for one laptop or iPad. I might have 20 devices that want to do a little bit. So 20 devices doing 50 meg a piece, there's a gig right there. 50 meg's a lot, in today's application. But I might have that many devices, or I'm trying to be my own ISP and I'm actually selling services to my neighbors.
You'd never do that, John.
No.
Don't give people ideas, man.
But really, you have speeds now that are more than what ISP started out with.
Yep.
Right? I mean, it's crazy. The type of speeds we're offering for residential. So to have that speed, I could divvy up the speed amongst different services and maybe different modems. So that was the idea, is I can get 10 gig to the house, but can I just use multiple modems to do 10 gig? 5 gig on one, 5 gig on the other. They're actually on their own separate channels.
It's an aggregation. It's kind of like load balancing, or it's a different way we can do it. So I like it. So Mel, he's saying, guys, thanks. All good. Thumbs up from the Netherlands. So shout out to everyone in the Netherlands. So he's getting a software upgrade on a CBR8 awesome to you. He's also saying if the backbone is using multicast, and so multicast for video delivery, I'm assuming he's using that to lower the usage of bandwidth. Is this possible on the CMTS, or will this stress the CMTS? So we're doing both multicast and DOCSIS video. So I don't see it. I mean, multicast is going to add more traffic to the CMTS. I think a question would be, from my standpoint perspective, John, is multicast able to be evenly load balanced on OFDM channels?
Yeah, I don't see any problem with that. None that I really know of. I mean, when you turn on more applications, you're going to have more CPU. I mean,
Yep.
that's the nature of the business.
And it's going to
But
consume, it's going to be competing for the same data that subscribers are competing for, right? I mean, it's
correct,
basically
correct.
utilizing capacity on the OFDM channel.
Yeah, but you're also you're providing content, and instead of how we do video today, where we have to send, say, 100 analog channels down the line, but we don't know what people are watching, but we have
Right.
to transmit them all, and they take up spectrum. Here, the whole idea about the multicast and that was, if everyone's watching, what do they call it, the long tail and the short tail of the traffic. If everyone's watching Netflix right now and it's the same show, then that content is it's like broadcast, but it's multicast to everyone that's watching the same show. So I can send
It,
it down at 10 megabits per second and not do a 10 for you and a 10 for you and a 10 for me, and because
Yeah,
we're all
I
watching
think
the same
what
content.
you're saying is that if everyone's watching Netflix, the cable operator doesn't manage it, so everyone's pulling it in from different points at different times, and you can't manage that flow. Whereas if you, as the cable operator, doing multicast, you have a better opportunity of managing that traffic, caching that traffic, and ideally reducing the impact on your network. So
Correct.
multicast, it is going to load your CMTS, but in theory, you may be able to have more control and make it more efficient on your CMTS than a standard over the top provider of video.
I think my concern would be in a DAA, distributed access architecture, your converged interconnect network, your SIN, your digital fiber, that multicast is going to eat up overhead on the SIN. And the SIN might not even be yours. You might be leasing digital fiber from some other third provider, or some other provider. So any of that overhead you're paying for, and maybe you didn't take it into account when you did some of your traffic engineering.
Right.
Even downstream maps for upstream scheduling, that's overhead on the SIN as well.
Right.
So every time I have lots of upstreams in the service group or lots of primary downstreams, I worry about how much map traffic, how much overhead do I have on my SIN that I didn't account for. Like you could have no DOCSIS traffic at all, but on
And you're
your
still going
SIN
to
you
have
still have
overhead.
traffic. Yeah, you have traffic running. Like, wait a minute, why am I paying for this? Mhm.
Absolutely. So Roman R, greetings from Germany. Hi, Roman. And Abraham says, can newer DOCSIS 3.1 modems use 5 OFDM spectrum channels instead of the 2 today? So I think we talked about that just a few minutes ago, John. We said, currently the DOCSIS specification says that DOCSIS 3.1 modems can just do 2 OFDM channels. So that's something like if we could do more, then we could get a lot more downstream traffic. But it's kind of like something that there were proposals and discussions at this latest Cable Tech Expo. There were some people talking, I think even the presentations on it. But I really don't know what's going to happen in the industry. I don't know if you've heard any rumors, John, and vendors are actually talking about adding this additional capability. If it's just rumors or if this is legit.
I think it's rumors at this point. We have our own. We're trying to push our own agenda as well, right? You and I talked at this show. There was the kick around of right now. It's a hardware limitation of the modem. And there's 4.0 spec coming out for FDX or ESD, extended spectrum DOCSIS, doing 1.8 gigahertz downstream and have the hardware in the modem to do multiple blocks of DMOD, right, and multiple blocks of upstream modulation and multiplexing. But right now, the 3.1 modem is hardware limited to 2 blocks downstream, 2 blocks upstream, and a single carrier QAM. If we could maybe just grab new silicon that could do the blocks, but maybe we didn't worry about FDX or we didn't worry about 1.8 gigahertz. And if we could get a modem with newer hardware in it, and then we said, I was kicking around, people said 3.1 plus and 3.5, and you and I joked about calling it 3.14, and we'll call it the Pi modem. So 3.14 is Pi. So we coined the term Pi. So if we could get a 3.1 modem that just had a little bit more oomph, and then, after I got done talking to you, I was thinking also, if I put the hardware in there to do more blocks, why not put the hardware in there to do higher modulation as well?
Yes.
Why not allow the 8K QAM and 16K QAM? If I can do it, I can do it. If not, but I'd rather have hardware that I pay for one time to get me to the 10 gig potential without even going down the FDX path or the ESD path.
Yeah.
Because I can do 5 blocks in 1.2 gigahertz. I mean, I just got to start eating into my video.
I think the struggle we have as an industry is we have just 2 chipset vendors out there, and they're working really, really hard to get DOCSIS 4.0 ready for us. So for them to spend energy going back and reworking the DOCSIS 3.1 chipset to add support for more OFDM and OFDMA channels, it's going to be really hard.
I think it would be a 4.0 chipset, but I wouldn't have to worry about the added complexity of FDX or going to 1.8 gigahertz. You know? So you know what? Give me a toned down version that has the higher modulation and has the multiple. For that matter, it's like I don't know. Could I put multiple chips in a modem? Like the idea of 2 modems, right? Why can't I have like 2 chips in one modem? So it really is 2 modems. But I'm just speculating there about how do I just get one modem, one device in the house to do more speed, right?
Absolutely. So we got some feedback here, Ron. Local trees, always appreciate the 100. Mel's, welcome. And Abraham loves the pod, John. So,
pumpkin pie.
When Happy Pie Day comes around, when Pie Day comes around, we'll do a big celebration on that.
Pumpkin spice.
Yes. So, all right, John, anything else on this topic for DOCSIS 3.1 modems and where we can take them?
I mean, in regards to the upstream, we know we're limited to 204. So adding more upstream channel capability doesn't do us any good. If I do this 3.14 or Pi modem, right, I need more downstream. And that would be one way to do it, is new downstream chip. Upstream chip, I don't see how trying to get past 4K QAM and 2 blocks is going to do me any good, because it won't. I don't have the spectrum for it anyway. And then we start getting into DOCSIS 4.0 with a 396 megahertz upstream, or ESD with a 396 upstream, or something even higher than that. But now you're going into the freaking weeds, right? With all the plant upgrades that need to happen and all the logistics. There's just a lot of stuff to bite off there.
Hey, Mel's Canal, and Mel, I'm sorry if I'm saying your last name improperly. I'm trying not to say your last name. Actually, you just said something in the chat room that made me, as John and I are talking about new ideas for DOCSIS 3.1 and DOCSIS 4.0. I think this is a really good comment you made. He said we have one PLC per OFDM channel. And as you're saying, you encountered an issue where interference collided with a PLC, and that, I'm sure, caused all your modems to go offline, as you're saying. So you changed the frequency, meaning you moved the PLC to a different frequency where you didn't have interference, and now no more problems. So how about PLC redundancy, John?
I thought in the spec, back when we started looking at resiliency and we talked about, a single carrier QAM DOCSIS 3.0 modem that only had one primary. I was always like, why couldn't we have 2 primaries, like a backup primary?
Yeah.
It's like an oxymoron, right? A primary, secondary, a secondary, primary. It's an oxymoron, but it's like, then when OFDM came out, like, why didn't they think of that? Why didn't they have multiple PLCs so you had like a backup for the physical link channel? But then when I looked at the spec and we did testing of our own, the PLC is like 16 QAM. It's like really, really robust.
Super low order modulation.
And it's not that it's 400 kilohertz or less of actual bandwidth. And you can put it wherever you want. So I told people, it's pretty robust. By default on RCMTS, it shows up, I think, right smack in the middle of your channel, but you have the capability and power to move it where you want. So I tell people, move it wherever you want, and keep it away from LTE, keep it away from off-air interference. If it hurts when you do that, don't do that. So you should know your plant. You should know where ingress might be coming in, and put the PLC where it makes sense. You might not want to put it near the very high end because you could have a high end roll off, and the modem doesn't lock or doesn't work anyway.
But this one megahertz, because it took the modems offline.
The other one is this one's philosophical as well. Do I make my OFDM primary? Is it worth making my OFDM channel a primary channel? Or, because you're going to cross bond with single carrier QAMs anyway, probably for a long time, because you have 3.0 modems, 2.0 modems. So maybe I cut down the number of primary downstreams on single carrier QAM from all 32 to like every 8th one. So there's only 4 primaries. That cuts down on the number of downstream maps and map traffic, but I still have plenty of primary downstreams. And I can see where you can make a case for not making the OFDM primary. Because if it's secondary only, I can go into partial mode while the modem's still locked on a 256 QAM, very stable single carrier QAM primary. Whereas the OFDM, once you lose it, you lose that entire channel, which is a lot of capacity, right? But you can make the other argument that PLC is very robust, the OFDM shouldn't go down. But as the case you just said, Mel just said here, he had his PLC in an area that was subject to noise and ingress, maybe LTE, 4G cell phones. And it could even be, I don't know where 5G is transmitting right now, but there's ingress all the time coming in from somewhere. And if you don't properly select a good place in the spectrum for your PLC, it's going to cause a problem.
And I want to point out, there is another tool out there. So Mel, maybe something you want to look into called PMA, the Profile Management Application. And it does do something that it'll continuously look at your RxMER and it'll identify if your PLC is in a place that does have high degradation. And it'll recommend the optimal place to put your PLC frequency. So that's also something that's another tool that you can look into for that.
I suspect if he had his OFDM as a secondary only, not primary, the PLC would have recorded a problem and the modem could have went to partial mode instead of going offline.
Yeah. So in partial mode, it drops the OFDM channel and falls back to the SC QAM channel. So, and I definitely hear what you're saying, John, about making the OFDM secondary. So it uses the SC QAMs first as your primary channel. But I think that is a stopgap solution, because as we look at DOCSIS 4.0 and the road to 10G, SC QAMs will eventually go away, and right. OFDM has to be our primary channel when there will be no SC QAMs, SC QAM being our legacy. So that's something that we have to consider as well.
Yep, of course.
All right, John. Anything coming up for you in the future? What's on your roadmap?
Roadmap. There's no real shows or conferences coming up.
Holidays coming up soon.
Yeah, so it's getting ready for people's quiet time. Where people will shut down their network, so you can't do any changes. Usually, that's a good time to give training, right? Because people are like saying, "All right, we shut down our network from any changes from Thanksgiving to New Year's," and then sometimes it goes even further into the bowl games and everything else, right? We don't mess with the networks, and that time is usually spent training. I think, which is a good opportunity to get people up to date with what's been going on. Problems that might have been seen. We're getting a little bit better information on OFDMA on the upstream. More people are deploying it. I remember the time you were working with OFDMA issues with noise-related issues.
And a lot of those have gone away, thanks to the maturity of the modem issues or maturity of the modem firmware and also the CMTS firmware. Well, we're seeing operators successfully operate OFDMA at the lower frequencies. I think it was probably a year ago we were saying don't operate OFDMA in a lower frequency spectrum, but we're seeing it's actually become pretty robust now in the lower frequency spectrum.
That's good. Yeah, we knew that. With the noise down there and the OFDMA, it was causing some issues and lockups or layer 3 ping issues or whatever. And we said, my philosophy was if I'm doing DOCSIS 3.1, I wanted to use it to its fullest advantage and take advantage of it. And that means higher modulation at the higher frequency, not trying to squeeze out a couple bits per second out of the lower frequency and opening up that noise. And so I was always kind of trying to promote moving up in spectrum and keep the single carrier qualms down lower.
Yep, absolutely. All right. With that, so I will be next week at in Tulsa, Oklahoma, for an SCTE chapter meeting. It's a vendor day, so we'll be doing cable games in the morning and a presentation and over lunch. So looking forward to seeing everyone in Tulsa next week. But same as you, John. After that, we got holidays rolling in and lots of cable operators shutting down. Well, not shutting down, but kind of freezing plants. So that'll be nice going into the holiday seasons. But between now and then, I'm sure we'll probably have another live stream. So I want to thank everyone in the chat room. It's been a nice active chat. So Mel, thanks. We'll look it up. And noise and CPD, we never deal with that in the cable industry. So John, thank you so much for joining us back again. This is a great episode. I think we had a lot of nice content we covered, and we'll get back in probably another month to catch up again. So John, so long. Thanks again. And everyone, please, hit the thumbs up and subscribe if you haven't already so you get notified of our next episode. Everyone, take care and so long.
All right. Take care.